start, even though it's a couple minutes early, just because this is condensed from a little bit of longer talk, and I can use all the time that I can get. So I'm going to talk today about automating performance optimization tasks for JavaScript applications. Right, so tell you a little bit about myself first. So I'm Matt Lancaster. I am a senior technology architect with Accenture. I lead a group called Lightweight Architectures that primarily deals with building single-page applications, APIs, applications built on top of JavaScript platforms, other things. So I have a number of folks who work on my team. And a lot of the things that we actually end up building, we put through a development operations process that uses various tools that we all know and love, like Grunt, Gulp, et cetera. And one of the major pieces of that is actually running the build of the application through a number of performance optimization tasks. So why would we do that? What is automation of performance anyway, right? So I think the key reason why we would automate performance optimization, or why we would want to even think about doing anything like that, is to make sure that performance optimization becomes part of the process, right? Becomes part of the just ebb and flow of daily development, so that as we're working through things and as we're doing things, it becomes part of the DNA of the development team, rather than something that people think about as an afterthought or something that people think about at the end when an application doesn't meet SLAs. Right? If performance is not part of the process, you can absolutely guarantee that it will be thought of only at the end, because we're all developers, we have deadlines, and we need to get functionality out the door, not necessarily optimized code and optimized application logic all the time. So performance optimization, at least parts of it, can be made automatic and can be added as part of the development operations process, so that we can all focus on doing manual performance tuning on the things that are really tricky and difficult and the things that matter, rather than the things that are relatively easy and easily automatable. So it's all about being lazy at the end of the day, right? As with most good automation tasks. So before we really get into the meat of what individual performance optimization tasks we can talk about, and all the good stuff in terms of the process and all that, I want to start with a couple of disclaimers. So great performance still requires great code. I think that one's pretty obvious, right? The amount of image optimization you're doing or removing unused CSS rules from a project, you can do lots and lots of that stuff, and if you write shitty JavaScript, you're still going to get a bad application at the end of the day, or something that takes like 5 seconds to load. So write good code is the moral of that story. It's the build process and DevOps process we're talking about here is not just the asset pipeline, so it's not just the end of it. It's certainly part of it, and running through concatenation and minification tasks and things like that. But we're also talking about adding code review and adding a few other things as part of the step-by-step process of daily development, so that we're getting automated checks and balances so that people can perform manual tasks appropriately and just are reminded to do them when appropriate. And you can't automate everything, but we can automate certain important things and give folks time to focus on the things that are a little bit more difficult. Right? If everybody is manually running all the images on their website or on their web application through JPEG Mini or something like that, and that stops that same developer from having time to go through and remove a bunch of nested loops or something like that. Those nested loops probably shouldn't have been there in the first place, but now they have the time for it, right? So, and then a quick caveat also, most premature optimization is bad. I think the architects of yore aren't shaking their fists at me from beyond the grave or what have you. So it's still a good axiom to follow that you don't want to optimize the application architecture prematurely. You don't want to go and add a bunch of message queues or load balancers and stuff like that prematurely. But what you can do is think about some things in an application that are just always going to impede performance unless you get rid of them, right? Images that aren't compressed, CSS rules that are never used in the entire application, unminified files in the case of JavaScript, et cetera, right? All those things, you always need to think about that as part of every application build. And if you don't think about those things, then you're selling yourself short and you're selling your users short. So what is automating the performance optimization tasks? I think the answer to that is pretty simple, right? Reducing the overall file size that is being downloaded, reduce the number of HTTP downloads that are happening before an application's loaded, reducing overall render time before the user can actually interact with a site, improving code performance as part of the automatic process. And we want to, once again, set up performance tuning tasks that we can, set those up as part of the build task, and also set up code review tasks as part of our automated DevOps workflow. So what does a sample development operations workflow for a JavaScript application look like? It might look like something like this, right? So a developer is working happily. They get their code written. Then they go to check it in. But before they can actually get it in the develop branch, they have to have perhaps unit tests written, have static code analysis passed via something like JSHint or JSLint, or one of the other newer ones that have come out. Run it through a code review system like Fabricator. Fabricator is one of my favorite tools and one of the few I get really religious about. Git is another one of those. Run it through a review tool, have some other folks look at it. We're all amazing developers and we never make any mistakes, right? But ultimately, having somebody else look at your code is still a good idea because other developers are really smart people too, and they can often show you things that you might have missed. So once it actually gets put into the repository, whatever CI system you're using, in our example case here, Jenkins, will pick it up, run it through the series of unit tests, behavior test tasks once again, with whatever automated tooling you're using. In this case, it's running it through Phantom.js, but you could just as easily run it through, say, Selenium with WebDriver or something along those lines. And then you're going to push it to Grunt once again for the performance optimization task. So you're going to do things like minify, concatenate, remove unused rules, and a number of other things that we're going to talk about in a moment. So, and once that all gets done, of course, you push it to whatever environment you're pushing it to, and then the QA folks can actually go look at it. So let's think for a moment about the common problems in all of our applications. Right? What are some of the common problems that we could potentially automate away, or common performance issues we could potentially automate away? So in almost every application that becomes mature, we're going to have a lot of CSS rules that were once used in the application and are no longer used in the application. Right? This tends to happen organically, and we get scared of removing them because they might be used on some page somewhere and we don't want to break it. But it's difficult to tell whether they're being used or whether some piece of JavaScript is adding them somewhere dynamically. Not the easiest thing in the world to do, right? Not having responsive images on a site with a responsive code base. So if you're supporting multiple devices with the same code base and you just put in large images, I feel very bad for your mobile users because they're going to be downloading very large images on a much smaller device in terms of the bandwidth capability and rendering capability, et cetera. And then having multiple media query definitions, having unoptimized images, so images that have additional metadata or haven't been compressed to the level that they can be compressed and still look good, et cetera. And then some other items that we'll talk about as well. So how would we go about solving a problem like this? Right? It's a kind of a tricky issue. In many cases, folks would do that manually through just running, running the image optimizers or running, running grunt tasks on their local machine, checking that stuff in. But here we're going to use, we're just going to use whatever task automation tool we have at hand. It could be Grunt, it could be Gulp, it could be any of the other ones that will likely come out. I'm a little frightened that all of our JavaScript task automation tools are named after body noises. So if anybody invents a new one, hopefully no more, please don't name it Swallow or something like that. What can't be done via that task automation tool and what can't be done via adding tasks to the task automator should be done as part of the development process, but should be done in such a way that you're having automated checks and balances. So if code reviews aren't performed, then audits get generated. If reviews aren't performed fast enough, then reminders are sent. We want to have code actually pushed so that people can see it and so that people can see the application. We don't want to create bottlenecks. But what we do want to do is make sure that, that folks have a helping hand and that the developers are getting good code all the way through. So tools of the trade, obviously Grunt or Gulp. I have a list of all the grunts and Gulp tasks at the end of the presentation that we use for a lot of this stuff. So I'll leave that up when I'm finished. But for the most part, I've tried to get parity, though of course there are more Grunt tasks than there are Gulp tasks out there. So sometimes there's just a Grunt task in place of where there would be a Gulp task, but I digress. So let's move into CSS, right? CSS is one of those areas where we can do a little bit of optimization. We might be able to do it in automatic fashion. So if we have very uncommonly used CSS rules throughout an application, maybe we might want to take those rules and inline them so that we're not making every page load all of those rules, right? And if we have a sufficiently large application that starts to return benefits as we remove 10, 20, XYZ KB from the application, right? And then, of course, even when it's done downloading, you still have to unpack and render all of those rules on each page. So you're dealing with some additional stuff there. So, and then, of course, the holy grail is if we have a bunch of rules that are not used, how do we just remove them, right? And that one is really dangerous, but also potentially very rewarding, right? So I think all of us use UI tools like Bootstrap or Foundation or hopefully not jQuery UI in 2014, but still some of that around, right? Where it has CSS rules loaded with it. Lots and lots of them, often enough. Many of the controls that you're downloading with those UI toolkits you're not using, but the CSS rules are still loaded in your application and they're taking up lots of dead weight. Right? So how do we get rid of those safely? There's a couple of great grunt tasks out there. One of them called uncss, which if you do your project structure very judiciously, you can take advantage of. If you don't make that project structure just right, then you're going to have scary results, as it'll take away CSS rules that are used by JavaScript and added dynamically and all that kind of stuff. But you can make liberal use of the ignore file, and you can add and you can remove a lot of rules that are there and are not needed. So images, I think images are always the big one. I think hopefully everybody remembers the little flame war that went around a little over a year ago around framework size. Everybody was complaining, that Angular was too big or that Ember was too big and that Backbone was tiny, so everybody should use Backbone. And so I think it was Adam Sontag who said something to the effect of, well, if you just remove one JPEG from your application, the whole framework size issue doesn't matter. Right? So we probably don't want to remove images because we like interactive media and we like nice rich applications, but do we really need to have uncompressed, unoptimized images on every device and on every screen, right? There's lots and lots of metadata that comes with images that you never see. When somebody edits them in Photoshop, Photoshop saves a bunch of metadata along with it. If you use JPEG Tran or JPEG Mini or the various PNG tools that do the same thing. You can often remove 5–10% of the file size without doing anything at all to the image quality. And removing a little bit of image quality here and there from each image can pay huge dividends throughout the application. And then taking a little bit more of a radical approach, making responsive imagery automatically from the larger sized images. So if you have desktop sized images and you want to make the tablet, phone, landscape, what have you, image sizes, you define your sizes. You use something like Grunt Clown Car, or there's a couple of other ones. The imager.js is also fairly popular for that, where you can create those images automatically. They're just automatically added to the source, and then it's added to your CSS files so that on the smaller viewport sizes you load the smaller images, and then you sort of automatically get the right size for the right viewport size. And then having sprites generated automatically as well. I think this was another one of those holy grails from around like 2011 that everybody was doing with PHP and Python and Rails, and then it kind of fell off the side of the world for a little while, and now we can bring it back with JavaScript and have the same set of problems again. So except now we get to do it with SVGs as opposed to PNG sprites. So there are a couple of really great tasks to do that as well, and if we actually generate sprites instead of a bunch of individual icons, we do actually see quite a bit of performance benefit just because we're loading a single image as opposed to going and downloading a bunch of other ones, right? And even if you have a fairly small HTTP transaction, that HTTP transaction still has a header, it still has handshakes that it needs to perform, a lot of overhead with even a fairly small transaction. So you want to make sure that those are as few as possible. And if you're just looking at a piece of an image from a CSS file, you're not loading a bunch of individual images, right? Of course, that can be abused, but in general, it tends to be a pretty good idea. And then JavaScript, of course, is the hardest one out of everything to do any sort of automated optimization. But we can cheat a little bit and say that we want to use the static code analysis tools that we have at hand. So make sure that linting is done and force that before code reviews happen. And then also use some of the newer linting tools that have been popping up on the scene, like ESLint or some of the other ones where you can write custom rule sets. So if you write custom linting rules around performance, say if you find something that a developer is doing and it affects performance particularly nefariously, just add a rule against it, and the project can grow its automated performance tasks sort of organically. I have a project right now where we've grown about 40 of those custom rules where we have folks using 2D transforms when they could be using 3D transforms, right? A fun trick on mobile web applications is that if you use a 3D transform even for 2D operations, it leverages the GPU on most modern mobile devices, so you get a little bit of extra processing horsepower. So my question there would be, why would you ever want to use a 2D transform again? So, writing a few rules to take advantage of things like that, you can certainly do that. And then making sure to code review, right? And then also making sure that whatever requirements tool that you're using, whether it's CommonJS, whether it's ES6, whether it's Require.js, that you're using that properly, hopefully asynchronously, but nobody's perfect. And then running all of that automated JavaScript code analysis before a manual code reviewer has to actually go through it and you inflict your code on someone else, right? Fix all the errors with it, and then they can fix the non-obvious errors. So I think in our DevOps process earlier, the inflection points for performance optimization are on the code review side or pre-code review side, and then also in the build process and things like that. There's a few things that I left out, of course, that I think are just kind of intuitively obvious, like doing minification, concatenation of files. If we're loading 60 JavaScript files on a page in production in 2014, that scares me, right? So concatenate your files reasonably. You also probably shouldn't. We also probably shouldn't have an 800 KB file with all of our JavaScript in it, because that's also scary. but a happy medium can generally be achieved that where we can have our cake and eat it too, right? And the same thing goes with CSS. So that actually ends the overall portion of the talk there. So any questions?
Is there a reason we shouldn't use jQuery?
Besides me being flippant, I think so, yes. I think it doesn't perform quite as well as a lot of the newer CSS only or CSS preferable UI widget frameworks. There's a lot of baggage in a lot of those components. They're using a lot of unoptimized jQuery. So you get, if you run them through like a JS Fiddle or JS Perf or something like that, you can see where they're orders of magnitude slower than just using CSS. Not 10 times slower, not 100 times slower, orders of magnitude slower.
Is that particularly animations, or is that like
Animations is one of the big culprits, and then also there's just a lot of random little images and sprites that are added. It was great for what it did, and when it came out, I think there are better options now. Yeah, so I mean, finding memory leaks is something I think we all deal with in JavaScript, right? And I think it's one of those things where we can add some of those custom rule sets. So if we find a set of developers that are adding, that follow a pattern that will lead to a memory leak, we just disallow that particular pattern in coding. Yes, so using something like ESLint where you can create custom rule sets. So something like ESLint, which is the grunt ESLint, I think it's the third one on there. So JS Hint, it has a single rule set, right? And you only have what they give you. ESLint allows you to add custom rules in the rule set. So if you want to add something that say, yeah, you write your own rules.
Any particular advice for optimizing like time of first render or just render time performance in general?
So the question was how to optimize just render performance in general. And I think there's honestly no easy answer to that. Just make sure that the size of the overall site is as small as possible, that your code is tight, and that you're not asking it to render 2 megs when you could be rendering 800 KB if you've optimized everything. A smaller size, a lower amount of files to be downloaded, et cetera, is always preferable, and then making sure to take as much advantage of asynchronous loading as possible.
Are there any tools for
There are. So there's a great tool called Plato that collects like the various code quality metrics, and I think it has some performance plugins. So I'm going to hop down here, and then I'll if there's any more questions, I can answer those in person. I hope so. If they're not, I'll put them on SlideShare.